Hi there. Today I'm going to speak about how we can build operational analytics applications which are backed by ClickHouse. I run a data and analytics consultancy, and I believe that ClickHouse is very well suited to applications of this type where we have very real-time data in which we need to make very immediate decisions based off of. And I hope to really bring that to life during this presentation. I'm going to start by talking through some of the concepts and what we mean by operational analytics. And then I have a few demos of applications to really bring the concept to life. So if we think about the approach which most companies take to business intelligence, they will typically have a setup like this. So you have these kind of source applications in your business and maybe some SaaS applications like Salesforce or Google Analytics. And what we want to do is kind of get the data from those source systems and get it into a centralized data warehouse or data lake in a standard format, so we have a history of what happened and the ability to do this joined up view from across a business. You would then typically build dashboards and reports which are given to executives and managers who would periodically review them to understand what has happened. Now, one of the many problems with this setup is just how slow and delayed it all is. So it's all based on this idea of, maybe every 12 or 24 hours you would extract data from these sources. Then after some more time has passed, you would load it into your data warehouse and do some transformations to make it ready for reporting and analysis. Then maybe you'd have to do a refresh in your business intelligence stack to bring the data forward so it's ready for presentation. And then maybe 12 or 24 hours later, a human would actually look at that report. Now, you could easily find yourself in a situation where it takes 12 to 24 hours between when the business event happens and when it is being reviewed on a screen. You can obviously get faster than that, but what you tend to find is a lot of the tools aren't really designed for this really immediate flow of data, and it can also become cost prohibitive if you have to run all of this infrastructure for continuous extraction and ETL, especially in these days of kind of SaaS applications, SaaS-based data infrastructure, where you are paying for consumption of compute. Now, I believe that we are moving more towards a world where businesses are demanding fresher, more real-time data based upon which they can make more immediate decisions. And that brings us into this world of operational analytics, which I define as the situation where we would like to use real-time data to make intraday decisions about our next best action. Now, there are many businesses and many people will say to me, we don't need real-time data. And I agree with that. In many cases, it's fine to understand what happened yesterday because you're not going to act on it anyway. But there are many industries where having this real-time view is much more valuable. For instance, financial crime is one we regularly come up against, where I want to monitor transactions to ensure that they are compliant and there is no financial crime. Things like financial markets, where I would like to analyze and understand my risk and what is happening in the markets is very real time. IoT scenarios where we are monitoring machines and equipment, and we obviously need to understand how they're performing right now and if there are any faults. Online gaming, understanding kind of customer and player experience. So there are many, many industries where operational analytics and real-time data is critical and valuable. Just to flag a few of these differences between these two worlds. So business intelligence, as we discussed on the last slide, it tends to be very backwards looking. So what we're asking there is what happened over the last week, month or year. And then we're going to use that to make decisions over long-term strategic time horizons. With operational analytics, we're more typically saying what's happened today or in the last few hours. And we're using that to say what is our next best action. What should we do right now in order to get the best outcome? So it's much shorter time horizons. In terms of the nature of that data, so in business intelligence, as we mentioned, it's very delayed and it arrives in kind of batches every 12 hours. Whereas in the operational analytics world, what we really want is immediate, fresh data which arrives continuously as the underlying business events occur. And that has big implications for the technology stack. We have to move into streaming data, reactive user interfaces, real-time databases, which is incidentally ClickHouse is great for. And in terms of how that's used, so the BI world is obviously quite static and humans are looking at it, whereas in operational analytics, we want to ask all of these complex questions about our real-time data, and we're more likely to hook up algorithms into that data, such as triggering alerts or closing down accounts if there is a financial irregularity, or shutting down a machine or something like that. So it's much kind of faster and more dynamic in the operational analytics world. I'm going to have some demos of these apps at the end, but just to kind of bring it to life visually at this stage. On the left, we have an application we built for a international payments business. It was a POC, but effectively what we're doing here is monitoring the transactions which are flowing through that business. And we are identifying which transactions have been blocked by our automated systems. And this is a tool which a financial crime analyst can use to understand and identify suspicious situations, such as maybe there's been a sudden spike in transactions by one particular customer in one particular region. We can understand that in real time and go and investigate it using tools like this. In the bottom right, we have a kind of financial markets oriented example where we are monitoring prices and calculating kind of parameters like how prices are changing and risk duration of bond portfolios and stuff like that. Now, as I mentioned, I think ClickHouse is kind of uniquely suited for building solutions like this. Many of our kind of transactional databases can't scale for doing the type of analytics that we need. And many of the kind of cloud data warehouses, they are not kind of fast enough or scalable to build apps like this. So let's focus in on ClickHouse and why it's such a great fit. So firstly, it's all about speed, right? We have all of this kind of data can be streamed in, and we can ask complex questions about that data and get responses very quickly, which is kind of a fundamental base that we need to build on. Now, also, we can do that against very fresh data, so we can stream data into ClickHouse immediately as the business event happens, and then ask questions about that data with very minimal pre-processing. And again, this is just something which traditional other databases just cannot kind of scale to meet this demand. ClickHouse then gives us kind of fast views and materialized views, so we can kind of pre-prepare our data ready for rendering. But that all happens based on what we call kind of insert trigger semantics. So as soon as the data is ingested into ClickHouse, we can build up those views and materialize views. And then later on, it will use these kind of what we call merge tree table engines to consolidate and clean up the data. But we're really giving ourselves the best chance of going from the shortest possible time from when data is ingested to when it is acted upon. It's great from a concurrency perspective, so we can take these applications and give them to users all across our business, or maybe even put them into the hands of customers. We could have thousands of customers who are interacting with our data in interesting ways. Maybe there's a little bit of kind of caching in there, but as a rule, ClickHouse is a better base to build these types of user-facing analytics. It has these kind of powerful analytical functions. So for numerical processing, some data science type functions I'm going to talk about. You can do array processing. And this basically can simplify your technology stack because you don't have to break out into Python to begin working with your data and applying maths and stats to it. You can do some of that directly within ClickHouse. And then finally, we have this kind of option of ClickHouse Cloud, which is a fully managed ClickHouse. And that really gives us, one of the key advantages is the auto-scaling. So if you have a sudden spike in data or a sudden spike in users, it will scale up to give you more capacity. And when all of those users are finished, we can scale down or even scale to zero to save money, and all of the data is safe. So I think ClickHouse Cloud is particularly good for these types of apps. Now, this is a bit of a philosophical idea, but I have started to think of ClickHouse not as a database, but as a backend for these types of applications. So what we can do is we can get the data out of the applications and into ClickHouse, and using features like materialized views, we don't need quite so much stream processing that we might previously have done in like Flink and Kafka streams. We can actually do that stream processing directly within ClickHouse. And likewise, in the old world, you'd often find I'd be writing like calculation layers in Java or Python, which would take the data out and process it in some way before presenting it on a screen. With the types of apps I'm going to show, what we are doing is building a front end directly against ClickHouse and asking mathematical questions about the data without any kind of intermediary layer. So again, sorry if this is kind of a philosophical idea. I think of it as like this backend for operational analytics applications. It's more than a database in some ways. Of course, today I'm kind of concentrating on front-end applications, but we've also done some work and we think that this stack is also great for machine learning inference. So if we want to incorporate machine learning into our products and we have to pick up data at runtime, we can ping back into ClickHouse and get that nice and quickly. And also for algorithms, right, for alerting or automatically closing accounts and stuff like that. ClickHouse is great and scalable for those use cases. So as I mentioned, ClickHouse, it does have these great kind of analytical functions which are embedded within it, and they can reduce the need for using Python. And we spent a lot of time playing with things like forecasting, anomaly detection, building recommendation engines, using functions which are native to ClickHouse and almost totally avoiding the need for Python. If you check our websites, we don't have time to go into this in great detail, but we have these articles. This one is about anomaly detection, and we have very detailed walkthrough and code samples describing how we would do it. This one is forecasting. And again, if you look at these, it's all ClickHouse SQL based. This is about machine learning feature stores. This is about solving a resource optimization problem. And this is recommendation systems. So do check that out. And I think that this is a really interesting angle of exploration with ClickHouse. Likewise, in terms of machine learning, it's obviously on everybody's radar with this kind of explosion in AI. We think that ClickHouse is a great fit for building these solutions, both in terms of training and exposing your training data, but then for things like observing how your machine learning algorithms are performing in production, and things like vector search, which can power large language models, and online inference and feature stores. So the final part of this kind of journey towards operational analytics applications is these reactive user interfaces. Now, when I first started using ClickHouse, the first thing I did was put business intelligence tools against it to begin to analyze the data. So these are tools like kind of Power BI, Tableau, Metabase, Superset, things like that. And you quickly find that those tools, they don't really do ClickHouse justice. They're basically kind of static business intelligence tools, and they can do charts and filters, but they're not what we need for operational analytics, right? In operational analytics, I want very real-time user experiences, including kind of simple things. It sounds simple, but like updating data without a page refresh. It just doesn't feel like I'm getting a view of the world if I have to kind of manually refresh data and refresh pages. But also in operational analytics, I want to build slightly more complex user experiences where I can drill down into data and I can click buttons and call APIs, and I can maybe render documents which I can give to staff, for instance job sheets. I want to kind of call out to machine learning environments and stuff like that. So I really need like arbitrary flexibility to build user experiences. So we've been doing some work in this space. We have our own user interface layer for building applications like this, which I'm going to show in just a moment. Just to flag what sits behind this, we use a technology called Cube, which allows us to query ClickHouse using REST and GraphQL APIs, and that will give you things like caching and additional security hooks. So if you're interested in this space and building these types of apps, definitely check out Cube. So I'm now going to get into a demo which will hopefully bring this concept to life to a greater degree. So here we are looking at the application we built for this fictional international payments business. And we can see that here we are tracking the volume of transactions that have occurred today. And if we look at this number, it is updating each time a payment happens within this business. So 37821, and then in just a moment another payment should occur, and it's gone to 865. So we're getting a real-time view of what is happening in this business, and there isn't any page refresh. These numbers are being pushed into the user interface, and we can see down here, this is the high-value transactions. Now, our kind of belief and aspiration is that these apps should be much more than just kind of static dashboards. They should be much more interactive, and we should be able to build user experiences which really aid the employees to do their job more effectively. We're also kind of very focused on integrating with machine learning algorithms and environments. So here, for instance, periodically we are looking at these volume of transactions and forecasting volume over a future period, and the data looks a bit crazy because there's just random data in our simulation. And we're also kind of thinking about how can we integrate things like large language models into these user experiences. So here I can say write a letter to David Smith asking for his source of wealth. This is something which maybe you have to do from a financial crime compliance perspective. And we also have some demos on our website of using these large language models to ask data about this real-time data in ClickHouse. So we believe that we can build applications which go far beyond dashboards. You know, they are going to be highly interactive. They're going to be designed to help employees do their job much more efficiently. They're going to integrate with machine learning models and integrate large language models, and just to really help people use data as part of their day-to-day operations. As a second example of that, I would use this demo that we have built for a logistics business. So here what they are doing is they are receiving orders for different food items, and here this particular order was for a place called Swindon in the UK. And if we go to we also have this business, they have a series of vehicles, so they have 20 vans. Each van has a different capacity, and the same for trucks, and the trucks typically have a higher payload. And our task here was to kind of complete all of the deliveries in the most optimal way using the fewest vans and trucks, such that the kind of capacity constraint was met. So in this example, when you hit this optimize button, we go and we call a Lambda function on AWS, which will run that optimization process to allocate the deliveries to trucks. And then when it comes back, the data is stored within ClickHouse, and you can see that that algorithm has suggested that vehicle ID 5 should drive to our Cardiff warehouse. It should then collect the order, and it should drive to Swindon, and it should deliver the fruit, cheese and vegetables. So this is like a kind of data science optimization problem, but we're taking the data kind of out of ClickHouse, we're doing the optimization, we're storing the results back into ClickHouse, and then we're putting it on this interactive application to help the employee be more effective at their job. Finally, from a kind of financial markets perspective, we're also experimenting with building user interfaces like this, where we have data which is being streamed in real time, and maybe this is from a crypto example, and we are building kind of this experience where if I refresh the page, initially we go back to ClickHouse to understand the state of the world. Then we begin listening to a WebSocket for ticking data to populate this React front end. So here we get in these really kind of real-time user experience of what is happening right now. And this is kind of leveraging the power of ClickHouse, but also kind of modern web technology, WebSockets, React, Next.js to build these powerful operational analytics apps, which could we believe could really move the needle for businesses in all kinds of ways. So hopefully that kind of made the case that ClickHouse is a great fit for building operational analytics based applications like this. And my feeling is that not many businesses are using data in this way, where we're kind of processing it in real time and then we're building really useful applications for our employees to allow them to make the next best action. When you get this right, there can be a massive business case. You can operate much more efficiently. You can build a much improved kind of employee and customer experience. You sprinkle in some data science and machine learning to really guide people towards the next best decision. It's a really powerful idea and a real low-hanging fruit for lots of businesses. So if you would like to discuss this space, learn more about how we build these applications, please do reach out. Contact details are here, and it's great just to learn how these techniques and approaches can be applied. So thank you very much.